A sphere of mass 4 kilograms, moving with speed 3 meters per second on a smooth horizontal table, collides directly with another sphere B of mass 5 kilograms moving in the opposite direction, with speed 2 meters per second. The coefficient of restitution between the spheres is 0.2. Calculate the speed of A and the speed of B after the collision. After the collision, sphere B collides directly with a vertical wall. The coefficient of restitution between B and the wall is 0.6. Find the magnitude of the impulse exerted on B by the wall. So there's the question then. The first thing, I've drawn all the information in the question. So after the collision, we can say that sphere A is moving in this direction with V1 and sphere B is moving with speed V2. And these are the speeds of before collision mentioned in the question. So conservation of momentum then. Of linear momentum gives we're going to go in the forwards direction then. So 4 3s are 12, and then it's minus 5 times 2, minus 5 times 2, because it's a negative velocity, isn't it? So I'll put the minus at the front, is equal to the momentum before equals the momentum after, 4v1 plus 5v2. So we've got 12 minus 10 is 2, is equal to 4v1 plus 5v2. That's equation 1. 12 minus 10 is 2. Now we know the restitution is E is 0.2, so also the restitution equation then the fact that E equals 0.2 gives, so the velocity after the speed they're moving away is V2 minus V1. So 0.2 will equal V2 minus V1 divided by the speed they're moving towards each other. And they're moving towards each other at 3 plus 2, isn't it? 5. So that's 5. So 5, move that up to be with a 0.2. So V2 minus V1 is equal to 5 times 0.2 is 1. So that tells us then that V2 is equal to 1 plus V1. This is number 2. Move the V1 over. We get this. So let's sub this in 1 then. Subs 2 into equation 1 gives, so 2 is equal to 4v1 plus 5v2. 5v2. 2 is equal to 4v1 plus 5v2, and we can replace v2 by 1 plus v1. So 2 is equal to 4v1 plus 5, expand the bracket, plus 5v1. So that tells us then that 2 is equal to 9v1 plus 5. So 9v1 is equal to, move the 5 over, 2 minus 5 is minus 3. Now move the 9 from times to divide. And v1 is equal to minus 3 over 9, which is minus 1/3 meters per second. So v2 is equal to 1 plus v1, 1 minus 1/3 then, which is equal to 2/3 meters per second. So that's the speed of A and the speed of B, meters per second. So we've done that, speed of A and B after the collision. So we better put it down as an answer. Speed of A then, well, it would be 1/3 meters per second. And speed of B is 2/3. These are the velocities, of course, and these are the speeds. So we drop the minus. If there is one to drop, which was here. So that's the speeds then. So now, so it's going forwards then with speed v2, and it's going to hit the wall. The coefficient of restitution is 0.6, and it's 5 kilogram going with v2. So we've got 5 going towards the wall with v2, which is 2/3. It hits the wall, bounces off it with a coefficient of restitution E equals 0.6 as we said, and it will be going back, won't it, with V3. So this is part B now. So here E 0.6 is equal to the speed it moves away, V3, over the speed it goes towards 2/3. So V3 then is equal to 0.6 times 2/3, which is 0.4. So the 2/3 you can move up to be with the 0.6, and that's 0.6 over 3 is 0.2, times 2 is 0.4 meters per second. So there's V3. So the impulse then is equal to the change in momentum. In this direction it's going, in that direction then it's reversed. So it's this plus this, isn't it? So it's 5 lots of 2/3 plus 5 lots of 0.4. This is 2, 5, 4, yeah, 2, and this is 10/3. 2 and 10/3 is what we've got here, which is 5 and 1/3. Newton seconds is the unit of impulse.